Hi, I'm Jack from Technocamps, and today we're going to be looking at using Python and turtles to draw some pretty interesting shapes and do some little bit of fun maths in between. So what are we talking about? Well, Python is a programming language, and as a programming language it's one of the most popular in science, engineering, maths and so on. So of course in computer science we use it to build software. In biology, it's good for modelling things, same for chemistry and physics. In maths, it's very good at drawing charts or processing data. And in electrical engineering, there's something called CircuitPython. And CircuitPython is very good for small things like LEDs, motors, sensors, that kind of thing. We're going to be doing a bit of Python maths today. And we're going to be using Turtle. So you should see in previous activity packs where we explain the concept of a turtle. However, before we can continue, you should have seen the getting started part. Now, Python can be run either from a piece of software called idle or from a website like EduBlocks. I'm going to be showing you how to use it with idle, but whatever method you use, it should be practically identical. But if in any doubt, make sure you go to the Getting Started with Python section first. So, what do we need? Well, when we're starting with Turtle, we need three things. One, we need to tell Python that we're using Turtle. And Turtle is a library, and by library I mean it's a set of codes that someone else has written for us that we can easily communicate with and talk to. And for that we're going to use the Turtle library, and the keyword for telling Python that we're going to be using that is import. So we say import Turtle. And as we can see, that's the first line down here at the bottom. We also need to give our turtle a name, and we need to tell Python that's a turtle. So I've called my turtle Bob, and I've said Bob equals turtle.turtle bracket bracket. There's a couple of rules when it comes to naming our turtles, and these are very important rules that need to be obeyed. One, it must start with a letter, the name of our turtle. Two, it must have no spaces in the name. And three, it must be sensibly short. Because we're going to be writing this name out a lot of times. If we make it too long, then that's a lot of extra typing, and that's not helpful to anyone. Finally, the third thing that we need for every single Python program that uses Turtle, well, we don't really need it, but it's optional. We can tell the turtle to look like a turtle. If you don't, it'll look like a boring arrow, but we want it to look like a turtle so we know what we're talking about. So we say bob.shape, and then inside the brackets we have speech mark, turtle, speech mark. Let's try this out. Let's start by writing this out in idle. So I'm in idle. So what's the first thing I need? Well, I need import. And I know I spelt it right because idle has turned it orange for me. What do I need to import? Well, I need to import the turtle library. So turtle. And then on the next line, let's do next two lines. It doesn't really matter as long as it's on another line. It's just depending on how easy it is to see and so forth. Let's make up a turtle name. I need to think of a turtle name. Well, it can't have any spaces in the name, and it can't start with a number, and it needs to be short and sensible. I'm going to call my turtle Simon. And now I've called my turtle Simon, I need to refer to it as Simon throughout the rest of the program. So I'm going to say Simon equals turtle.turtle. Okay, all I'm telling Python is Simon is a turtle. Okay, then I can set the shape of Simon. So I'm going to say Simon.shape. And then inside the brackets, I'm going to have speech mark, turtle, close speech mark. Okay, before we run it, let's just do a code check. So, there must be no capital letters in the import turtle part. Do I have that? Yes, no capital letters. Bob equals turtle.turtle. The name of your turtle must have no spaces. That's correct. The first turtle has no uppercase. And the second turtle has one capital T, and only one. And it has an open bracket and a closed bracket at the end with nothing inside it. Do I have that? Yes. So, no capital letter, one capital letter, and open bracket, close bracket. Finally, Bob.shape. Well, I've got Simon.shape. Between the brackets there should be turtle in lowercase, surrounded by two speech marks. So one at the beginning, one at the end. A lot of problems comes from people not using speech marks and using two apostrophes. If you do that, it will go wrong. Let me show you. So if I make the mistake of having no speech marks, it's gone black, meaning it's not going to work. It should be green. If I have two apostrophes instead of one speech mark, now I've got two apostrophes there and two apostrophes there. See, it's black again. That means it's wrong. Let's put the speech marks in as it should be. So speech mark, speech mark. There we are. That all works. Okay, now we can move on to the next bit. So, to move the turtle, if you remember back to the previous activity pack, we had the commands forward and right. Now, in Python, the way those work is you have the name of your turtle. In this slide, the name is Charlie. You say name of the turtle dot forward and how much you want it to move, and name of the turtle dot right and how much you want it to turn. Remember that this, whatever's in the right, is the number of degrees. Let's write these out and see what happens. So, on the next line or two, I'm going to say Simon.forward. How much is it going to move forward? Let's say 100. And on the line underneath, I'm going to say Simon.right. And he's going to turn right 90 degrees. Let's watch this. Okay, so I'm going to save it. Let's save it just anywhere. Let's save it on desktop. Now I need to give it a sensible name, and the name must not be turtle. If you call it turtle, it will break. So I'm going to call this one simple line. And let's click save. Sudden surprise jump cut, but we're back. Before the quick break, I was going to show this running, so let me run that. There we are. That is our program running. So let's look back at the code. We had Simon.forward 100, and then he turns right 90. Let's look at the code again. Sorry, let's look at the turtle. So that's forward 100 and then turn right 90. And we can know for certain that that line is 100 pixels long. So, where were we? Well, we've moved the turtle. What next? Well, now we've got those two commands, we can use those commands to draw a square. So, if you pause the video now, have a go at drawing the square yourself. And when you're back, around about now, then I will go through this with you. So let's draw a square. So we've got one side of the square, we've got one side, and we've got one angle. So I need to repeat that. How many times? Well, this is a square, so I'm going to need this 4 times. So Simon.forward 100. Why is it 100? Well, this is a square. All the sides are the same length, so they're going to be 100 pixels each. That's because I've decided what that number is. If I change this to, let's change it to 200, I need this one to be 200 as well. Let's have Simon.right. This is a square, so it's always going to be 90. It can't be anything else, otherwise I would have a different shape. 200. Simon.right. 90. Simon.right. 200. Oh, no, that's wrong. It's very easy to get distracted. So I've got 1, 2, 3, 4 sides. That's done, but I've only got 3 angles, so let's finish off the last angle. So you should have 4.right, and you should have 4.forwards. And that leaves 8 lines total to draw a square. Let's test it. Run module, save it. There we are, perfect square. What happens if I change this number to 300? Let's run it. There we are, we've got a bigger square. Okay, what happens if I wanted to make a rectangle? What would I need to change? Well, I'd need to change 2 of the sides, won't we? Because a rectangle has 2 long sides and 2 short sides. So which of these are going to be the short sides? Well, I'm going to go for that one and that one. Let's have these ones being the short ones. So let's choose the number smaller than 300. Let's choose, I don't know, 50. Do the angles change? No, this is a rectangle. There we are, long rectangle. Okay, so that was the next task. It was to draw a rectangle. However, now we've drawn it, we need to rotate it the other direction, just to show that we can do it. So mine is a very tall, vertical rectangle. If I look at my code, what would I have to change about my code to get it to be a wide horizontal rectangle? Pause the video, give it a see yourself. And we're back. Let's try it. Well, if I want to switch which sides are the long ones, which ones are the short ones, I need to swap around the numbers. So let's change that one back to 300. Change that one to 50. That one back to 300. And that one to 50. Let's run it. There we are. I've now changed the orientation of that rectangle. Brilliant. But there's a problem. What happens if we want to draw more complex shapes? Now, when I draw out a rectangle, I start with a line, and then my turtle turns 90 degrees. And what the turtle is doing is it is turning the exterior angle of the rectangle. So if we were doing a more complex shape like a hexagon, we need to find out what its exterior angle is. What is an exterior angle? Well, if you've got any regular polygon And by regular, I mean, it's every side is the same length, and every interior angle is the same, and every exterior angle is the same. Now, in any regular polygon, the exterior angle is what you get if you imagine a side carries on longer and you measure the angle between the outside arm of the shape, outside this one, you measure that and this imaginary line here. So what is that? Well, if this is the interior angle, then the exterior angle is 180 minus the interior angle. So we can see that this, if you extend this line along, you get a line, and of course a straight line is 180 degrees because it's half of a full circle. So the exterior angle is this part. And if we look at the shape as a whole, when it comes to regular polygons, if you add up every single exterior angle, you get 360 degrees. That's what that adds up to. So, using that, we can actually work out what an exterior angle of a shape is by doing 360 degrees divided by the number of sides of the shape, and that gives us the exterior angle. So let's do an example. Let's go back, we've got a hexagon. We need to find out what is the exterior angle. So all we do is we do 360 divided by the number of sides, which is 6, and that equals 60 degrees. 360 divided by 6, divided by the number of sides. And there we are, 60 degrees. What happens if we're doing a square? Well, a square has 4 sides, so we do 360 divided by 4, and that equals 90. So that is why we are turning right 90 degrees when we're doing our rectangle, because that is the size of the exterior angle. Also, it just so happens to be the size of the interior angle as well. But that's only for squares. When it comes to a hexagon, it's a different value. See if you can work it out yourself. So, pause for a second. Try drawing a hexagon using Python Turtle. Think about what degrees do we need to put in the dot right function. Think about how many forward commands we need and how many dot right commands we need. I'll give you a second, and that second has passed. Let's give it a go. So there's my rectangle. I can get rid of that. Okay, so this is a 6-sided shape. So that means I'm going to need 6 dot forwards and 6 dot rights. So what I'm going to do is I'm going to be very cheeky and reuse some of my code. Just copy and paste. How many have I got? So 1 forward, 2 forward, 3 forward, 5 forward, 6 forward, and 6 rights. What should the values be? Well, it's a regular polygon, so every single side needs to be the same amount. So I'm going to go about changing all the size to 100. That one needs to be 100. There we are. And what angle does it need to be? Well, this needs to be the exterior angle. And to find that out, 360 divided by 6 equals 60 degrees. So change that one to 60, 60, 60, 60, 60. Okay, if my calculations are correct, we should have a perfect regular hexagon. And there we are. 1, 2, 3, 4, 5, 6 sides. And because it's regular, we know that it's drawn the angles perfectly. Okay. So now you know how to do that. The next challenge is draw a heptagon. A heptagon is a 7-sided shape. We know that the calculation is 360 divided by 7. But if we are a little bit cheeky, we can actually get Python to do all that maths for us, so we don't have to bother working it out. Okay, so if I were to try and work this out either by hand or, like me, cheating with a calculator, let's find out what 360 divided by 7 is. So 360 divided by 7 equals 51.4285714286. That's a mouthful. I don't want to have to be dealing with numbers like that. That's just a pain. So rather than copying that number and putting it inside my code, I'm just going to get my code to do the division for me. Let's go back. I want to draw a heptagon. It's a 7-sided shape, so I need one more dot forward and one more dot right. Let's copy those and paste those. And what do I need to do? Well, I need to find out the exterior angle. We know it's 51 point something or other, but that's a pain. So I'm just going to change each of these to 360 divided by 7. Now, of course, if you look down at your keyboard, there is no divide symbol. So instead, we use a slash. And make sure it's the right slash. It's the one where the top is facing towards the right. I can't remember whether that's a backslash or a forward slash, but yeah, it's just that one. Okay. 360 divided by 7. 360 divided by 7. 360 divided by 7. You get the gist. I'm just going to copy and paste the rest. Okay, so every time it's doing a dot right, it's working out that maths for us. We don't even have to care that it's an awkward decimal. We don't care that it's 51 point something or other. Instead, we've got Python doing it for us. So let's see, do we get a perfect heptagon? There we are. 1, 2, 3, 4, 5, 6, 7. Perfect heptagon. No worries. Okay. So, as I'm sure you've noticed, mostly by the way I've been copying and pasting everything, but every time we draw a side of a shape, we're using 2 lines of code. We're using a dot forward, which draws the side, and we're using dot right some amount to turn the exterior angle. If we wanted to do a more complex shape, like a decagon, a 10-sided shape, how many lines do you think we need in total? So how many forwards would we need? How many dot rights would we need? And how much would that be altogether? Well, it would be something like this. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 dot forwards, 10 dot rights. That's 20 lines of code altogether. That's a pain. That's pretty awful. It's too much bother. In fact, so much bother, I'm not going to even bother running this. I know it draws a perfect decagon, and I know it's a pain having to write all that out, even with copy and paste. So, what if I were to tell you I could draw a perfect decagon using only 3 lines of code? Impossible, right? Not quite. Now, because those lines are repeating being the key word here, well, why don't we get those lines to repeat for us rather than writing them out over and over and over again? And for that, we're going to use a for loop. What a for loop does is it calls a tiny little variable called I. I starts at 0, and every time we complete one dot forward and one dot right, we add 1 onto I. So I goes 0, 1, 2, 3, 4, 5, 6, and so on, and it stops before it reaches the number that's inside this range here. Now, if the number is 5, that would it would repeat these two lines of code 5 times. If this number was 72, it would repeat these two lines of code 72 times. Where I've set this variable, this box, this storage container to equal 10. So every time I talk about number of sides, I'm talking about number 10. So this is counting from I equals 0 to 10. So it means you'll do dot forward and dot right 10 times. We're also using number of sides next to the division. This is so we don't have to change both of the numbers here and the numbers there. I'll show you what I mean. This is our code for a heptagon. That's a load of rubbish. Let's get rid of that. Let's do a decagon using only 3 lines of code. So for I in range, how many sides do I want? I want 10 sides. So let's put 10 there. And then I put a colon, then enter. And we can see that it's moved my cursor away from the left. The way that Python tells what's inside the for loop and what's outside the for loop is how far away from the left it is. So let's do Simon.forward. Let's do 50. And then we do Simon.right. It's 360 divided by 10 because we know that we're turning the exterior angle. Let's try this. Let's run that. And there we are. Perfect decagon in only 3 lines of code. What happens if I want to draw a let's say let's say we want to draw a tetradecagon. So a tetradecagon is a 14-sided shape. What do? We change the numbers. So in here we put how many sides we want. We want 14 sides. And here we say what's the exterior angle. The exterior angle is 360 divided by the number of sides, which is 14. So let's say, will this draw a tetradecagon? There we are. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Perfect. Okay, let's say I wanted a dodecagon. A dodecagon is a 12-sided shape. Now, to do that, I'd have to change this number and this number. But imagine, that's a lot of effort. What happens if I forget to change one of them? What's going to happen? It's going to cause an error. It's going to not draw the right thing. So let's say I forgot to change this one to 12. I forgot to change this one here. Let's see what happens. Oh, it stops early. So we've got our 12 shape. We've got our 12 sides, but it hasn't linked up. And that's because we forgot the number. We put it in the wrong place. So rather than having to change both these numbers twice and possibly forgetting how to do one of them, we're going to store that value in a variable. So above our for loop, let me add a little bit of space. I'm going to make a variable. Now, like turtle names, it mustn't start with a... It can only start with a letter, and it mustn't have any spaces in it. So I'm going to call this num of sides. And I'm going to say num of sides is equal to 12. Let's put that in here. Num of sides. Num of sides. Notice I'm being very careful to spell it exactly the same way each time. Because if I spell it differently, it won't understand what I'm talking about. Let's run this. And there we are. Perfect dodecagon. Let's try a 42-sided shape. I'm not sure what that's called. Let's change that number to 42. Notice I only have to change it once now. And that's a lot less effort for us. Let's run it. Ooh, there we go, it's off the page. That brings us on to the next task. So I would like you to pause this video and have a go at drawing your own, well, shape. So pick any number between 1 and 100 and change the number of sides to equal that. However, if you look at mine, you see it's gone off the page. You might need to choose a smaller value to put in the forward. So here my forward is 50. Let's change that to only 10. Let's see if it'll fit on the page now. There we are, it fits on the page. Interestingly, what does it look like? It looks like a circle, doesn't it? Well, it's not a circle. It's definitely and undoubtedly a 42-sided shape, but there's so many sides that it begins to look more and more like a circle. So let's choose a smaller number. Let's change that to... let's have that as... Let's just do 25. A 25-sided shape. There you are. That also looks like a circle, but it's less like a circle than a 42-sided shape is. Let's change that to... let's just do a 8-sided shape in octagon. That doesn't look very circly at all. Let's make that bigger. Yeah, that doesn't look much like a circle. It's all jagged. But if we put larger numbers as the number of sides, it looks more and more like a circle. And in fact, mathematically, a circle has an infinite number of sides. And that's how a circle works. It's the number of sides is set to infinity. We can't do that in Python, but it's that's how a circle is mathematically defined. It's a regular polygon with an infinite number of sides. Okay. So what's next? Well, say we want to draw two shapes. Now, to draw two shapes, all we have to do is we have to run another set of commands afterwards. But there's a problem. The turtle, when it's traveling from one shape to the next, is still going to draw a line. So, for that we need to use pen up and pen down. I covered this much more thoroughly in the worksheet for the previous activity pack, so take a look at that, and that should explain things a little bit more solidly. But let's say I want to draw two squares. Have a go around this code. I'm going to run it a bit, just pause this video, see what comes out. Okay, let's run this. I'm not going to copy and paste because we're using for loops here. For loops are easy. They're nice and not too much effort there. So what was it? It was the name of the turtle. So for I in range. We're drawing 2 squares, so it was 4. Let's have Simon go forward. Let's say 100. Let's double check with that. No, it was 200. Doesn't really matter. I just want this to be large enough to see. Simon.right 90. Okay. Now I need to add more code after this, but look where my cursor is. My cursor is still inside the for loop. That's going to cause issues for us. So I need to press backspace, and now I'm outside of the for loop. Okay, so dot pen up, Simon dot pen up, Simon dot forward. It was 40, wasn't it? Simon dot, I think he went right next. Let me double check. Right 90, forward 40, left 90. So right 90, Simon dot forward 40. Notice I very sneakily have added a new command, Simon dot left. What do you think dot left does? Well, it does exactly the opposite of dot right. So dot right will turn clockwise, dot left will turn anti-clockwise. Okay, then it's pen down again and another for loop. Simon dot pen down. Notice I'm putting absolutely nothing in between the brackets after pen up and pen down. If you put something in between it, that will cause issues. So for I in range for Simon forward 120, Simon dot right. Let's see what this draws. There we are. And it drew a square. Now what happens if I'd forgotten the pen up and the pen down? Let's forget both of them for now. Let's see what happens. See, it connects the two. Whereas I didn't want it to be connected, I wanted them to be separate. Okay, so let's add this pen up back in. But imagine we've forgotten the pen down. Let's see what happens if we never put the pen back down again. Okay, pen goes up. Oh, and he carries on drawing, but he doesn't leave a line behind him. He just moves around. So the pen down was quite important there. Let's run that. Yeah, back to how it should be. Okay. Now, we can do some interesting things. We can change the pen colour. Now, this makes for some very interesting uses. And we can find which colours to use using this link down here. But I'm just going to write the name of my turtle dot pen color, and notice it's spelt with no U in color because it's spelt the American way. And then inside 2 speech marks, I put what color I'm going to use. Okay, let's just reuse old code. I'm feeling a little bit lazy. I want this to be, let's say red. Okay, where do I put it? Well, I always put the dot pen color at the start of the drawing instructions for the shape I want that colour. So, Simon.pen colour, open speech mark, red, close speech mark, close bracket. Let's see what happens. And there we are. It draws it in red. Now there's an extra command we can use if that's a bit hard to see. It's very thin, isn't it? Let's make that a little bit wider. We can say Simon.width, and then we can use a number. Let's say 5. That means that it's going to change the pen color, so it has a width of 5 pixels. Let's run that. Oh, what have I got? So if you make a mistake, the Python shell tells you what that mistake is. So it's always very important to read these errors. So in my file, on line 8, there is a problem. It says turtle object has no attribute width. Basically, I made a spelling mistake. So let's look on line 8. Where is line 8? Line 1, line 2, line 3, line 4, line 5, line 6, line 7, line 8. Doesn't know what width means. Let's change that to width. Run that. There we are. And our line is much thicker. What happens if I want the inner square to be a different colour? Well, for this, remember that the .pen colour command always goes before the shape that we're trying to draw. So this is the code to draw the outer square, and we've got the .pen colour at the start. This is the code for the distance in between them, and this is the code for the inner square. So if I want this to be a different colour, I could go before it, and I could go Simon.pen colour, and then in the brackets I can give it the right colour to use. What colours can I use? Let's go to that website I showed you, trinket.io/docs/colours. So trinket.io. This is the website to use, and it shows all the available colours. So let's go for, that looks like a very nice blue. That's navy. Do I want navy or do I want midnight blue? Let's go navy. Okay, so inside here, I'm going to write navy. Okay, and there we are. We've got a navy square in the middle. So that is pen colour. That's all very useful. And here's the challenge. I would like you to draw a square with every single line a different colour. This is much, much easier if you don't use a for loop. So if you go back to using all 8 instructions, so 4 forwards, 4 dot rights, and think about it where we might need to change dot pen colour in the middle of that. And as I say there, as I've misspelt, as typical, it's not width, it's width. Sorry about that. For some reason, that is the one word I always make a typo on. Ignore it. It's meant to be width. Yeah. It's very embarrassing. Anyway, make it so that every single line of a square is a different colour. And if you pause it now, I'm going to move on and show you. So let's get rid of all this. Right, I want to draw the first line and I want it to be a certain colour. Let's make it thick, just so it's easy to see. So Simon.width. Notice I spelt it the correct way, W-I-D-T-H, not width. I'll never live that down. Anyway, Simon.width. What size is that going to be? Let's make it a very thick line. Let's make that... Is 10 too thick? We'll see. Okay, I want to draw the first line using a certain colour. So before I draw it, I need to set the colour. So Simon.pen colour. What colour am I going to use? Let's try guessing a colour. Let's not use the website. Let's try see if leaf green is a colour. Now, if we type in a colour and it doesn't exist, then Python will tell us off. But that's fine. It just means we need to try something else. Let's see if leaf green is a colour. I can't remember if it is or not. Right, what do I need? Well, I need a Simon.forward. How much? Let's be generous. Let's say 200. Simon.right. And this is a square. So the exterior angle of a square, 360 divided by 4 makes 90. Okay, so that's one side. Let's do the next side. Control C, Control V, Control V, Control V, and I'm just going to change the colours. Very lazy, but oh well. Let's change this one to, let's see, if purple. Let's change that one to, let's use midnight blue. And finally, can't think of another colour. Let's just be boring. Let's just use red. Let's see if this works, and let's see if leaf green is a working colour. Ah, no. So it isn't. And the reason we can tell, if we look in the Python shell, so line 9, there's a problem. And if we look down here, what's the problem? Bad colour string. It means bad colour. It doesn't know what leaf green is. So let's change that. Let's change that just to... Let's see if dark green is a colour. Let's run that. And there we are. Dark green is a colour. And there we are. A nice, colourful square with every single side a different colour. Righto. What happens now if we want to fill it in? Well, for filling things in, we need 3 things. We need to tell Python what colour we are going to fill it with. We need to tell it when we want to begin filling and when we want it to end filling. So, fill colour needs to go at the start. Begin fill needs to go before our shape, and end fill needs to go at the end. Let's do that. Let's get rid of these. Let's just go to plain boring black square. If you don't set a colour, it will just use black. Okay, so what do we need first? Well, we need to tell it what fill colour we're using. So Simon.fill colour. Notice colour is spelled the American way. What colour? Let's be boring. Let's have red. What else do we need? We need to tell it to begin fill. So Simon.begin. Now, let's move on a slide. Here's the code for it. We have begin underscore fill, open bracket, close bracket. Let's try that. Begin underscore fill, open bracket, close bracket. And then what do we have at the end? Well, at the end, we have end underscore fill, open bracket, close bracket. And notice there is absolutely nothing inside the brackets at the end of begin fill and the end of end fill. The only time we have things inside the brackets is for the fill colour. So, where's the end of my shape? My shape starts here on this line and it ends on this line. So I need it afterwards. Simon.end_fill and 2 brackets. Let's run this. And there we are, we filled in a shape. Brilliant. So, my little challenge for you. Draw 2 squares. One has a gold outline and a royal blue fill, and the other has a red outline and a sea green fill. And they should be standing apart, and they should not be joined. Okay, let's give this a try. Okay, so let's get rid of that. So, what was my first square? I believe it was gold and royal blue. So let's set the outline. So Simon.pen color. Let's see if gold is a color. If not, we're going to have to try something that's closer to gold. Okay. Now we want to set the fill color. So Simon.fill color. And the fill color asks for royal blue. Now we can start, this is before our shape, so we can start our begin fill. So Simon.begin_fill. What next? Now we can draw our shape. Now, this is easy with a for loop. So for I in range, we're going to draw a square, so 4, because 4 sides. Simon.forward 100. Yeah, 100 will be fine. Simon.right 90. Spelt correctly this time. Now we've finished our square, so I need to end the fill. So Simon.end_fill. Now notice the position of this end fill. If I made a mistake and I had my end fill there, it would try and end the fill after drawing every single side, which means that it will never fill in the shape. Instead, we need to make sure it's outside of the for loop. Right. Now I need to get over... Let's check whether things are working first. Let's see if we've got that right. Let's save it. Press OK. There we are. We've got a gold outlined square filled with royal blue. Now, if I want to draw a square over here, what do I need to do? Well, I need to lift the pen up. I need to go over there, put the pen down, and draw another square. So let's try that. So, Simon.pen up. If the length of my square, if the length of one of its sides is 100, and I want to go apart from that square, I need to choose a value that's larger than 100. So Simon.forward, let's say 150. Yeah, let's say that. What do I do once I get there? Well, I do Simon.pen down. And now I can set the pen color and the fill color for the next square. So Simon.pen color. What did this ask for? Red and sea green. So let's have that one as red. And what the fill color was sea green. Now we need the begin fill, so Simon.begin. I can't spell today. What's that with me? There we are. Now, simplest way to do this is with for loop, so for I in range, for Simon dot forward. Do we want a bigger or a smaller square? Let's just keep it the same, just for continuity. Simon dot right. It's a square, so this needs to be 90. What have I forgotten? Any guesses? Yeah, I've forgotten the end fill. If I forget the end fill, it won't fill in the shape. It just won't. It will just leave it completely boring white inside. Let's run that. So it finishes the first square and does the second square. And there you are. That's how to draw multiple shapes. If you want to expand on that, what can we do? Well, I've shown you how to do 2 squares. Think about creating the Windows logo. See what you can do with that. 4 squares. Yeah, see how far you get with that. But in the meantime, the next activity you can move on to is drawing a flag. So this is a little bit more complex. I mean, that looks almost like a flag. What could I do to improve it? Well, I could remove the outlines and instead put the outline all the way around, and I could leave the I can make these narrower. So we could do semaphore flags, which are quite easy. They're 2 triangles, one yellow, one red, next to each other to form a large rectangle. There's the French flag, German flag. If you want to challenge the English flag or one of the other flags that uses a plus symbol, the checkered racing flag. So that's lots of small squares, all the same size, some black, some white, and they just alternate. The Scottish flag is very difficult. There's some very interesting angles involved in that one. And of course, the most difficult flag to draw, really, is the Welsh flag, because think about all the angles involved drawing a dragon. So if you can do that, that would be most impressive. In fact, I reckon you should even tweet that or send that on Facebook to Technocamps. And yeah, that would be pretty impressive if you can do that. Anyway, that's pretty much it from me from now. And yeah, hope you enjoyed, and I hope you end up with some good, interesting drawing.